Hello, and welcome to another Reigate Maths video. In this video, we're going to be looking at the bin packing algorithms from the first year of the decision unit for the A-Level Further Maths. My name's Simon, and what we're going to start by doing is talking about the point of them. So we've got a bunch of boxes, in this case 3, of size all the same. So the key thing with these algorithms is that the boxes, or bins, are all the same size. We then have objects that we're looking to put in those bins. And the idea is we want to use as few bins as possible. Now there are 3 algorithms, or 3 versions of the bin packing algorithm that we need to worry about. And we're going to look at each of them in this video. The first one is the first fit algorithm, where we have a list of the sizes of objects and we just put them in the first bin that fits. The next one is first fit decreasing, in which we sort the list of objects into descending order of size and then apply the first fit algorithm. The last one is full bin packing, in which we find combinations of items that fill the bins, and then we look at what's left and use first fit algorithm for those. Before we start looking at the algorithms themselves, though, we need to look at something called the lower bound of the algorithms. So the lower bound is a term that comes up a lot in decision maths in general, but particularly in decision, where we want to know the smallest possible outcome. Now, for the whole bin packing process, we assume that if we need a new bin, we can just have another one. Okay, so if it turns out that we need more than 3 bins for all of our objects, then we just have a 4th. The lower bound tells us the fewest number of bins that is required. And the way we work that out is we do the sum of the sizes of all of the objects divided by the bin size. Okay, remember the key thing about the bin size is that they are all the same. If you start changing the size of the bins, then the algorithm is pointless. So this is really useful, but quite often this will come out as a decimal. So we round up. Okay? So if we use this and we have maybe 4.7, then our lower bound for number of bins is 5. Now, it might not be possible to use the lowest bound number of bins, and that's, again, very consistent with the way the lower bound works in decision maths. It's a number, but it might not actually be achievable, but it gives us a baseline to work from. The other thing we need to worry about with this topic before we start looking at the algorithms are the pros and cons of each of the algorithms. Like, why are they good? Why might we want to use one over the other? So let's first look at the first fit algorithm. A big advantage is that it is very quick to implement. We just take our list of objects and we put them into the bins. It's very, very quick to implement. But the disadvantage is it's unlikely to give a good solution. And what I mean by that is, out of all 3 of them, the first fit is the least likely to get close to or meet that lower bound. So first fit is great because it's really quick to do if you have a ton of bins. But if you have a finite number of bins, which is more likely because in a practical sense, you have to think about the cost of hiring or producing each of these boxes or bins. The first fit is not great. The first fit decreasing is relatively easy to implement. Because it's effectively the same as the first fit algorithm, just with a little bit extra on top. So it's pretty easy to implement and often gives a good solution. But it's like the first fit, unlikely to give the optimal solution. So first fit decreasing typically will give us a better solution than the first fit algorithm, but it is unlikely to get to the lower bound. Full bin is the one that gives the best solution, usually. Okay, this is the one that is most likely to get us that optimal lower bound number of bins, but it can be difficult to implement. Now, for the purposes of the exam, the questions and the sets of boxes that you're going to be given, the full bin is not that difficult to implement. But in a practical sense, if you've got a lot of objects, then it makes it awkward to do unless you have another algorithm that pairs up things to certain numbers, which is what the full bin algorithm is doing. So you need to be able to talk about the advantages and disadvantages of each. Could be a question, and it's effectively one of these options. So difficult to implement if numbers are plentiful, so there's lots of them, or awkward. So if the numbers aren't nice to look at and add up to the size of the bins, then it's a bit of a pain. So what we're going to do now is look at how each of these algorithms work using an example. The example itself is relatively straightforward. We're going to have a small-ish number of bins, and then we're going to apply each of these algorithms to them. So this is the example we're going to be working through. So we can see we've got our list of items here. The sizes of each of the items are in the brackets, and we want to pack these items into bin of size 25. First question is determine the lower bound. So we calculate the sum of the sizes, and we divide by the size of each bin, so 25. Very quickly on the calculator we can add up all the sizes and we get 117. So 117 divided by 25 gives us 4.68. So therefore the lower bound is 5 bins because we round up. So this is what we're aiming for. Now the first thing we're going to do is we're going to apply the first fit algorithm. So this is the easiest one to do. We don't have to, we just go from there. So what I like to do with this is lay out kind of a little table, because I find it helps me keep track of things. And what's also quite useful to do is add up the total as you go, so you can very quickly see how much space is left in each bin. Okay, so first fit, we just go from the left, work through to the right, and remember the size of each bin is 25. So in the first bin, we're going to put A, which is size 8. And you might want to check them off as you go. I'm not going to for this video because we're going to use them again for the other algorithms. Okay, and we've got a total of 8 in there. So we've got tons of space. We've got 17 space left. Now, if you don't want to count up and want to count down so you know how much space is left, you can do that as well. It's up to you. But we've got space for the B as well. So we put the B in bin 1, and we can see that we now have a total used space of 15. So we've got 10 left, which conveniently is perfect for size C. So bin 1 is now full. We can't put anything else in bin 1. So we now move to bin 2. Bin 2 has space 0, so we can put D in, which has 11, which gives us 14 units of space left, which fits E in. So now we've got 24 units of used space in bin 2. So we've got 1 space left, but we can see that's not really going to give us anything else. So we have to move on to bin 3 to put F in. Now F has size 17, which gives us space of 8 left, which is great because G fits in this one. But then H doesn't, and we have to put H in the next bin. Okay, and we keep going. There's space left in this bin for I, but we do have to check how much space is left. Conveniently for us, I doesn't fit in either of the other two. Now we look at J. J has 14. So we have to put J in a new bin because we've only got space for 7 left. And then we can put K in this last bin as well. We can't put J and K in this last bin because it doesn't fit. So this is something you've got to be really careful of. It's very easy to just start assuming things are going to happen. So K doesn't fit, so we can cross that one out. So we have to put K in its own bit. And that's our orientation for the first fit algorithm. We can see we've used 6 bins, which is above this lower bound. And we've got quite a bit of wasted space, which is the downside of it. So let's have a look at doing this for the first fit decreasing algorithm. Now, because this list is in alphabetical order and not numerical order decreasing, we need to do that first. So this is very typical in an exam, is to get you to do either the quicksort algorithm or the bubble sort algorithm first to put these in descending order and then apply first fit decreasing. I'm not going to do that. I'm going to go and just put these in order now, and then we'll apply the first fit algorithm to that new list. Okay, so I've put the list in descending order. Notice it has to be descending. If you've watched the videos on the bubble sort and quicksort, numerically we typically do those for ascending order, but you don't have to. Again, this is something they might get you to do in the exam, is do one of those first to put the list in descending order and then do this first fit decreasing. So I'm also going to work out how much space we've got left, because it sometimes can make it easier to see, but it does require you doing a little bit of arithmetic in your head. So now once we've got these in descending order, we just apply the same algorithm as we did. So we've got F, which is 17, in bin 1. And so we've got space 8 left. K can't fit in bin 1, so we've got to put it in its new bin. And that gives us space for 10 left. J is 14, gives us space for 11 left. And now we're starting to get towards ones that fit. Okay, so we've got I, which is 12. I forgot E as well. E 13, there we go. So we've got space for 12 left. And now we can see, well, I doesn't fit with F, because we've only got 8. Doesn't fit with K, doesn't fit with J, but does fit with the E we've just put in. Whoops. We've got I with 12. And now we've got no space left in this bin. D fits nicely with this J. Got no space left in that one. And C fits nicely with this K. A, likewise, fits very nicely with this F. And then we can see B, H, and G are going to add together to give us 17. So they're all going to fit in this last bin. The key thing is that we've got to do them in the right order. So we've got to do them B, H, and G. Okay, and that gives us space of 8 left. So we can already see that this first fit decreasing is better than the first fit because we've hit this lower bound number of bins. It took us a little bit of time to put these in descending order, which is fine if you can do that quickly. And that's the issue with first fit decreasing, is that can be sometimes quite taxing to do. The last one, full bin packing, is all about spotting pairs yourself. So this is very, very important that you're good at arithmetic, because we need to see very quickly numbers that add up to 25 or as best as possible. Fortunately, we've already done a lot of that. The thing with full bin packing is there are lots of possible options. Okay, because we could have A, B, and C that add up to 25, but also F and A add up to 25. It's really up to you which sets you use, but you want to try and use, obviously, as few bins as possible, which does make this a little bit of a pain. Okay, so I'm going to say, well, we've got A, B, and C, which makes 25. And then if we look, we've got G, which is 4, H, which is 6, making 10, and K, giving us 25 as well. From there, we can now see we've used A, B, and C, G, H, and K, so it makes it a lot easier to spot left. And now we can see that E and I and D and J also add up to 25. And then the last one, F, we just have F on its own. The really good thing about this full bin packing is it's very quick to see immediately how many bins you need. Okay, we can see we've got 4 bins that are going to be full, and then 1 bin that is not full. Now, obviously, with this full bin packing, we could have just looked at what we had up here for our first fit decreasing and just use those options. And that's fine. But to show you kind of different options, I did it this way. The layout of our final answer is exactly the same. So we've got bin 1, which is A, B, and C. Bin 2, which is G, H, and K. Bin 3, which is E and I. Bin 4, which is D and J. And then bin 5, don't forget, F. And that's it. Okay, those are the 3 different types. You need to know all 3. You need to know the differences between them and the pros and cons of each. Now, part C says which of the above algorithms gives you the optimal solution and why. we've done 3, and actually it's either 2 or 3. So it's either first fit decreasing and the full bin give the best solutions. Because they use the number of bins equal to the lower bound. If it happened, and it's not really likely, I don't even know if it's possible off the top of my head, but if one had more space left than the other, which saying that now does make sense, then you would pick the one that has the less space, but remaining. But that doesn't make sense with kind of the way numbers work. So these are the 3 options for bin packing. These are the 3 you need to know, and you need to know how to deal with them. There was one more video in this series on the first chapter, algorithms, which is going to deal with the order of algorithms. But this here is how the bin packing algorithm works. Thank you for watching.